Hi, everyone. Here we're going to be talking about exploring quantitative data. And we're going to be following on the previous quantitative data analysis series of videos. And in this series, we're going to be covering scatter plots, measures of variation, describing and comparing quantitative distributions and robust statistics. A lot of this content is also from chapter 2 of the book we are using, and specifically section 2.3. Scatter plots of paired data. A scatter plot is a graph which provides a case-by-case view of data for two quantitative variables. So it is what we call a case-by-case because it actually graphs the specific cases, the specific instances, or the specific records of the data. And it's focused on two quantitative variables. One in this graph here, one is total income, and the other is loan amount. Two quantitative variables that are graphed with usually a dot, but it can also be another kind of shape like squared or circles or triangles. And often if you want to differentiate between groups, you may use different shapes. So for example, this data here may be from individuals in the United States. So each dot is an individual, and each individual has both a total income and a loan amount. So let's talk about this individual here. Let's assume this is Jane, this individual here. This is Jane. Jane has a total income of about here, which is about 60 or not 60. So this must be 50, right? 50K, 150, 50K. So this is about a little less than 50K, and loan amount is 20K, 20,000, 50,000. By paired data, when we say the two variables are for the same instances, they are paired. So we have a data set where Jane, we have, and all of these other individuals have both a total income and a loan amount, and that data was captured in the same data set or for that same individual within the same scope of time or other reference that ties them together. Each case may be named or anonymous. So in this data here, we don't know if it's named or anonymous, but sometimes we will actually have an identifier of what the dot is or what the records are. So these can be countries, and the identifier would be a country name. These can also be individuals, and the identifiers could be social security IDs or names, or the data could be de-anonymized. Anonymized, so made anonymous, and we would not know what the name or identifier of each individual unit is, although, of course, we may have some unique ID for each unit, but it doesn't really identify the person or the kind of object we are discussing. When we are reading scatter plots, there are four considerations, four attributes that we want to pay attention to. So first is form, and essentially we want to see if it's linear or non-linear, the general aggregate pattern. Now, sometimes it might be difficult to see if it's linear or non-linear. So for example, in this previous example here, we kind of see some a correlation and some direction of the data. I don't know if you can see, but to me, I see something like this here. Like there's a trend that when total income goes up, the loan amount also goes up. So we can say there's a kind of linear, but it's very dispersed. So these dots are very dispersed around it. They don't follow along this trend line closely, but it's still kind of linear. Now, In this other example here, we see a kind of linear. You could almost draw like kind of like a similar line like this. So you could say, well, it's linear kind of like this, as though in the other direction than the previous graph. But although we could say kind of does follow this pattern, at least for some of it, right? So if we delete here and then say, oh, for this part here is kind of pretty linear. But this relationship would be non-linear because this trend line is much better and this trend line is non-linear. So this graph here is a non-linear relationship. The direction has to do with where the values are going in respect to the two variables plotted. So if they're going in this direction over here with this slope in this shape, that's a negative association, meaning that as one variable goes up, so on the x-axis goes up, the other variable goes down. We can see here all these individuals that have high poverty rate also have low median household income. And let's note these individuals here, the observational unit probably is what? Are they persons? Are these, each circle is a person, each case is a person, or what? Probably not a person, probably a city, locality, or country, because these are aggregate measures, median household income and poverty rate percent. A person doesn't have a percentage poverty rate. A person is in the poverty line or not, and so on, but not a poverty rate. So these must be some kind of localities, each circle. So going back to direction, this way is a negative direction, and then the other way that we just saw before, this is a positive direction. Positive direction, one goes up, the other goes up. Negative direction, one goes up, the other variable goes down. Strength has to do with how closely the points follow a trend. So if the points, cases, or individuals are very close to that trend line, we say that the strength of the association is strong. Strength is essentially strength of the association. If they don't, like in this one, we say that the strength is weak. And this one seems pretty weak because look how far these points are from this line. Here, they seem much closer, right? There's a lot of them and they are much closer, all these points, to the trend line. Outliers has to do with how many unusual observations we see outside the overall pattern of the scatter plot. And here, I wouldn't even say these are that unusual. These all seem to follow. So there's little outliers, if any, here. Here, we kind of see some outliers. There's one all the way over here. So that's the other measure to read and evaluate the scatter plots. When do we use a scatter plot? Pause the video and think about it. Well, essentially, when we are interested in visualizing the relationship or association between two quantitative variables. So anytime you want to see the association between two quantitative variables, you may use a scatter plot. Here we have another one with a Gini coefficient, which is a measure of, whoa, what's going on here? A measure of inequality of a country or a region. And then here we have risk of theft in business. So kind of business theft, business crime. So we can see that in each observational unit here is a country. So as the Gini coefficient goes up, that is the inequality, the income and wealth inequality goes up in a country, we see a kind of association that the risk of business crime also goes up. As we were saying, the strength, the form here is linear, seems kind of linear. The direction is positive, meaning that inequality goes up, business crime goes up. The strength is kind of weak, right? Because these are, look at this point here. All these points are kind of far compared to these ones here. So we have a lot of dispersion. And lastly, outliers. There's not that many. There's a few. There's a few maybe. But even this one here, this kind of follows, look, this follows close to the trend line. So it's not really an outlier. So it seems a little bit, a few outliers. Notice that all we're doing here is very exploratory. This is why we call this exploratory, because it's not very precise. So they're based on visualizations and initial observations of the data. Let's also remember that just because we plotted something, we see an association, does not necessarily mean causation. And we'll keep repeating that throughout this course. That's it for this one. See you next time.